So now I am starting my third lecture, third class on quantum mechanics. So according to the Rayleigh-Jeans law of radiation, it came out like this: E lambda is equal to 2 pi c kt by lambda to the power 4, and we saw that it violated the at low lambda, low values lambda. It has no problem with lambda for higher values, but at low values of lambda it had problem. It shoots up like this. So I mean, it violates here. That is called as the ultraviolet catastrophe or the Jeans paradox. Okay, so now what happened? Still now nothing has been really confirmed about this black body radiation. It hasn't been theoretically described. So in the year 1900, Max Planck, in the year 1900, Max Planck proposed the Planck's hypothesis. Okay, proposed the Planck's hypothesis. Now, what is the Planck's hypothesis? Now, Planck's hypothesis was that actually, Planck found out that there might be some problem. Actually, there might be some problem in this thing, that is this epsilon a, the calculation of the average energy of the oscillator. We have taken the equipartition theorem. That is, equipartition theorem is nothing but basically it is a classical approach. Okay, if equipartition theorem is a classical approach. Okay, it is actually obtained from Maxwell distribution function. It is actually obtained from Maxwell's distribution function, which is a classical approach. Okay, so now Max Planck in the year 1900 came out with a hypothesis called as the Planck's hypothesis. According to the Planck's hypothesis, the energy of an oscillator can assume only discrete, this is a very important term, only discrete values given as epsilon is equal to n epsilon naught is equal to, where epsilon naught is the minimum energy, is nh nu. Okay, nh nu, where n is an integer, including 0, where n is an integer including 0. Okay. H is, everybody knows, that is, H is the Planck's constant. And nu is the frequency of oscillation of the oscillator. Okay, so this is actually the Planck's Planck's law or the Planck's quantum hypothesis. This is actually the Planck's law or the Planck's quantum hypothesis. Okay, so now what is this actually? So suppose say NH nu. Okay, what did I write? E is equal to NH nu. Okay, so what can be the values? So what the values can be, say where n is 0, 1, 2, 3, all the integers. So it can be 0 h nu, 2 h nu, 3 h nu, 4 h nu, like this. Okay, to infinity. So what can you see here, that it is it is the integer multiples of this h nu is called as the quanta of energy, one quanta of energy. Okay, so it is the integer multiples of h nu, and it can take only discrete values. Discrete values means it can take 0, then after 0, between 0 and h nu there are so many things. Means it can after 0 what you can write, say 0.1 h nu, 0.2 h nu, then like that till h nu. Okay, but no, these values will not be there. These values will not be there. After 0 you will get directly h nu. Okay, so see the continuity is broken. Discrete is the opposite of continuous. Okay, discrete is the opposite. Discrete is the opposite of continuous. Discrete is the opposite of continuous. Okay, it can take only discrete values. This is the main difference between quantum mechanics and classical mechanics. That is that energy of the oscillator to kt. Now k is a constant. Now t can take any values. T can take say 0.1 t, 0.2 t, 0.3 t, like that. It can take continuous values. There only lies the problem, that in actually the oscillators cannot take continuous value. It can take only discrete values, and discrete values of multiples of integer multiples of h nu. Okay, integer multiples of h nu. So now the h is the Planck's constant. What is the value of h? 6.62 into 10 raised to minus 34 joule second. Everybody must remember this. So now just like I had done in the laser lecture, laser is also based on all quantum principles. Okay, suppose this is the ground state of the oscillator. Okay, so what will happen? It will absorb energy. This is the ground state, means its energy is how much? 0. It will somehow absorb energy and go to the excited state. Say this is h nu. Okay, it will go to the excited state h nu. Then again, suppose it absorbs some energy, it will go to second excited state. This will be 2 h nu. Then it will go to the third excited state, that is 3 h nu. Then fourth excited state, that is 4 h nu. Then fifth excited state, that is 5 h nu. Then sixth excited state, that is 6 h nu, like this. Okay, so these are all, you see here, these are discrete. These are discrete energy levels, not continuous. If it would have been continuous, then in the middle of h nu and 0 there would have been many levels. Between 3 h nu to h nu there would have been many levels like this, but it is not. Okay, so similarly from 2 h nu it can go to 3 h nu. Okay, similarly suppose when it is this is absorption. When it is emitting, means after say 10 raised to minus 9 seconds it is coming down, then it will come down to here, then after this it will come down to here, after this it will come down to here, like this. Okay, this is absorption, and this is absorption, and this is emission. This is absorption and this is emission. Okay, so actually this is actually the Planck's law. Okay, so uh, according to Max Planck, the change in energy, according to Max Planck, the change in energy of an oscillator, can only take place in discrete form, the amount of energy emitted by the oscillator, or absorbed by it in a single step of change is called a photon. Okay, in a single step, the amount of energy emitted by the oscillator absorbed by it in a single step of change is called a photon. This is a photon actually carries a one quanta of energy, that is h nu. This is the energy of a photon in a single step of change is called a photon, and its value will be h nu, which is equal to the loss of energy, in case of emission. And gain of energy in case of absorption. Okay, in case of absorption. So this is actually the Max Planck hypothesis. Or I mean, it depends on the marks what is given in the exam. If it is 2 marks, you can write this nh nu also, that is the energy of an oscillator is always the discrete amount of quanta of energy, that is it is given as nh nu, where n is an integer. It varies from 0 to infinity. Okay, so this is the thing. And h is a universal constant. Everybody knows h is a universal constant. Okay, so now how will we that is verify the law? How will we change the Rayleigh's law, that is epsilon a? You have to find out the average energy of the oscillator, right? You have to find out the average energy of the oscillator. Okay, so that is written as epsilon a, right? So average energy of the oscillator will be what? Total energy of the oscillators divided by total number of oscillators, right? Total energy of the oscillator divided by total number of oscillators. Now total energy of the oscillators are what? Suppose suppose there are in this ground state there are n1 oscillator, in excited state, first excited state is n1, here n2, here n3, like this. Okay, so total energy of the oscillator will be what? It will be summation of nn. Okay, it will be summation of nn into epsilon n. That is epsilon n is what? Epsilon n is the energy of the of the state, that is the energy of this is epsilon 0. Okay, energy of the ground state is epsilon 0, energy of the first state is epsilon 1. So if the energy of the ground state is epsilon 0 and there are n1 number of oscillator, so what will be total energy? N1 into epsilon 0, and here it is n0 into epsilon 0. Okay, and here are n1 oscillator and the energy epsilon 1, so n1 into epsilon 1. Here number of oscillator is n2 and the energy is epsilon 2, so n2 into epsilon 2. So total you are adding nn into epsilon n divided by total number of oscillators, so summation of nn. Okay, very easy. Achha, now very interesting thing is that this summation sign, why I have used summation sign, I have not used integration sign. Why? The reason is, some of you can maybe answer probably. The reason is that this thing discrete. If I would have done integration, then that would have been for continuous thing. Integration is through all the continuous thing. Okay, summation is that is n is equal to 0 to n is equal to infinity. This n is equal to 0 to n is equal to infinity. Okay, so that is the thing. So I mean, that's why we are using summation, we are not using integration. If you have done integration, that would have been continuous. Achha, now you have to do this nn. Okay, so how will you write nn? Nn is nothing, nn is equal to n0 into e to the power of minus nh nu by kt, and epsilon n is what? Epsilon n is just this thing only, nh nu. Epsilon n is nh nu, so this will be nh nu, and here again this is the same, n is equal to 0 to infinity, n is equal to 0 to infinity, and nn will be what? n0 into e to the power of minus nh nu by kt. This is actually nn is the actually the Maxwell-Boltzmann from the Maxwell-Boltzmann distribution function. Okay. That is how will you write this? That is I in the again that in the only I have written, that is laser I had written, that is n2. Okay, actually nn is equal to n0 e to the power of minus, it is what, minus en minus e0 by kt. Okay, n0 into e to the power of minus en minus e0 is what? En minus e0 is actually this nh nu by kt. So from here I have written this e to the power of minus nh nu by kt. Okay. Okay, so now you have got this thing, so n0 will cancel out. Okay, so now what will you do is that you will do this thing. This is summation of n is equal to 0 to infinity and nh nu e to the power of minus nh nu by kt divided by summation of n is equal to 0 to infinity e to the power of minus nh nu by kt. So now there is actually not much physics but mathematics here. So what will you do now is that you will do here is equal to, you will write h nu x into 1 plus 2x plus 3x square plus 4x cube plus dot to infinity divided by, this will be 1 plus x square plus dot to infinity, where what is x? Where x is equal to e to the power of minus h nu by kt, e to the power of minus h nu by, where x is e to the power of minus h nu by kt. Okay, so this is the thing. Now you can do it yourself, do it little bit home task you do. How? From here, see here, I mean uh, h nu is coming common. Okay, h nu and I mean e to the power of minus h nu I am taking as common. Okay, so I mean basically the first term I am taking 1 h nu, so h nu e to the power of minus h nu by kt I am taking as common. So what will come? 1 plus here it will come 2 into e to the power minus 2 h nu by kt. So it 2x it will come plus 3x square plus like this. Okay, so those who cannot do, you just do it yourself, you can do it. Okay, just one step I have done a jump. Achha, so what will you do here now? So this will be, this is the series expansion. So 1 plus 2x plus 3x square plus this, what will be this will be 1 minus x whole to the power of minus 2, and this will be 1 minus x whole to the power of minus 1. Okay, so what will this be? This will be actually h nu by 1 by x minus 1. This will be this. Okay, h nu 1 by x minus 1. So now what will you do now? So this will be what is this actually? So this from here, this is epsilon A, the average energy of the oscillator. So this is what is coming, h nu by 1 by x. X is what? E to the power of h nu by kt minus 1. So e to the power of h nu by kt minus 1. Okay, so now you will the other part of the Rayleigh-Jeans law was okay. So u lambda d lambda 8 pi by lambda to the power 4 epsilon a into d lambda. This was the Rayleigh-Jeans formula. What Planck had done, that he has I mean modified this epsilon a, okay, by the quantum theory, that is Max Planck's theory. So what you can write, this will be equal to 8 pi by lambda to the power 4 into h nu by e to the power of h nu by kt minus 1 into d lambda. Okay, into d lambda. So now if you this is in nu. Okay, so but this is in lambda. So u lambda, from here you are going to here, from here you are again coming here. So u lambda d lambda will be what? 8 pi by lambda to the power 4. Acha, h, this is what? C by lambda divided by e to the power of h c by lambda kt minus 1 into d lambda. So this will be what? U lambda d lambda will be 8 pi hc by lambda to the power 5 1 by e to the power of hc by lambda kt minus 1 into d lambda. So this is called as the u lambda d lambda. This is called as the Planck's radiation formula. This is called as the Planck's radiation formula. Okay, this is called as the Planck's radiation formula. So in this way this was modified. Okay, so now now let us see what happens now. So now just like in Rayleigh-Jeans law, you had found out for lambda tends to infinity and lambda tends to 0. Here also we will do that. So here case 1 is when lambda tends to infinity. Okay, when lambda tends to infinity, what happens? this x hc by lambda kt tends to 0. Okay, hc by lambda kt tends to 0, so u lambda d lambda is equal to 8 pi hc by lambda to the power 5. Okay, so hc by lambda kt tends to 0 means hc is very small. So when this is very small, you can expand it. So this will be what? 1 plus hc by lambda kt plus hc by lambda kt whole square plus other cubes, higher order minus 1 into this d lambda. So higher order, this is higher already, hc by lambda kt is very small, plus this is square, so this can be ignored. So this will be what? This will be 8 pi hc by lambda to the power 5. This 1 cancels. So this is lambda kt by hc. So hc cancel into d lambda. So this will be 8 pi by lambda to the power 4 into kt into d lambda. Okay, 8 pi lambda into, so so I mean you see that I mean there was no problem actually for Rayleigh's law. There was no problem in at higher frequencies, higher wavelength. So here also there is no problem at higher wavelength. So this is the same. This is the same as the Rayleigh's law. This is the same as the Rayleigh's law. Okay. Achha, then comes your case 2 when lambda tends to 0. So this will change now. So case 2 when lambda tends to 0. Okay, when lambda tends to 0, then what happens? So exponential, so the lambda tends to 0 means what? hc by lambda kt will tend towards infinity, so it is very high. So then e to the power of hc by lambda kt. So okay, so e to the power lambda kt, what will happen? E to the power hc by lambda kt will be much greater than 1. Okay, so then in that case, what is the Planck's law of radiation? U lambda d lambda is 8 pi hc by lambda to the power 5 e to the power of sorry, it is 1 by e to the power of hc by lambda kt minus 1 into d lambda. So now if you apply this, in this case what will happen? It is very high. E to your hc by lambda kt is much greater than 1. So what will you get? 8 pi hc by lambda to the power 5 e to the power of hc by lambda kt into d lambda. Okay, you know, hc by lambda, I mean, sorry, e to the power of minus hc by lambda kt. Okay, so hc by lambda kt. So now I mean, so I mean here you can do that. This is the energy density of radiation. Now E lambda, that is intensity of radiation, is C by 4 into U lambda. So C by 4 into U lambda will be what? So 2 pi H C square by lambda to the power 5 into e to the power of minus hc by lambda kt into I mean this only. Okay, so actually so this is what? So this is actually the Wien's empirical formula. This is actually the Wien's empirical formula. This is actually Wien's empirical formula of intensity distribution. Intensity distribution of a black body. Okay, and here lambda t is the exponential. This is the thing. So I mean, so what are you seeing here? That in case of high wavelength, the Planck's radiation law converts to the Rayleigh-Jeans law of radiation, and in case of low wavelength, Planck's radiation law converts to the Wien's distribution law of Wien. So in this way, what is it? The ultraviolet catastrophe in this way was solved. Okay. So in this case, if you plot here, if you plot this thing by the if you explain the graph by the Planck's radiation law, then the experimental graph and the this graph will be the same. Okay, experimental graph and the graph, that both will be the same. What will actually this and this will be superposed only. This red line and the black line are the same thing only. So what did I see? What did I tell? That Rayleigh-Jeans law was okay for higher frequency, higher wavelength, but what was not okay for lower wavelength. So if you use Planck's radiation law, what are you saying? That at higher wavelength it is